let's make sure we know how to use that compounded interest formula when we're getting payments more than once a year by looking at kind of a standard savings account that we might see. So most savings accounts end up giving you your interest monthly. Of course, it can vary, but that's, I believe, the most common here in the US. So if we're being advertised a 2.4% APR on a savings account, how much is that account going to be worth after 2.5 years if we invest $3,500, right? If we just put $3,500 in the account, right? So first things first, let's identify what all these numbers really are. Okay, so our principal here is going to be this P0, which is $3,500. Our advertised annual percentage rate was 2.4%, which means we need to write that as a decimal, 0.024. Our N is the number of times we get interest per year. It says monthly, so that'll be 12. So that's monthly. And then finally, T is the number of years that we leave it in the account. So it says 2.5. I'm just going to write that as 2.5 because I hate mixed fractions. Okay. So that's all the stuff that we need, right? So we want to know what its value is going to be after those 2.5 years. So that is our principal times 1 plus our APR over number of compounding periods times number of compounding periods times number of years. Okay, so our original principal is 3,500. Our APR is 2.4%, which again I need to put in as a decimal, 0.024. Our N here is 12, and that's going to go up here also, times our number of years, so 2.5. Okay, before jumping into my calculator, let's make sure we're doing the order of operations correctly here. Okay. So, whenever I write something like this where both things are in the exponent, right, I've got this multiplication up here, but if we go by our PEMDAS, right, our order of operations, it says parentheses, okay, we'll do that here, exponents, oh, I better do that first, and then multiplication. No. When both things are written up here, there's an implied parentheses, okay? So make sure that you're doing this as a whole chunk and this as a whole chunk before you exponentiate. Okay? Of course, I know I need to do this division before I add on 1. So when I do 0.024 and divide by 12, I get 0.002. I add on 1 to that, and that becomes 1.002. And what am I going to raise that to a power of? 12 times 2.5. Which is 30. Okay, so this is the thing I want to find. So as I put that into my calculator, I'm going to get, let's see, 3,500 times 1.002 raised to the 30th. And of course, make sure your calculator is doing that exponentiation before it does this multiplication. And I get $3,716.21. Okay, so that's how you would use this formula in this kind of straightforward situation. I'm going to make one more video where I've got a slightly longer calculation to make sure we've got this.